So good morning everyone. So today I will be discussing with you all on the concept of molecular orbital theory. The molecular orbital theory is mainly proposed in as hybridization, and the arrangement theory, which was proposed earlier, was unsuccessful in explaining some of the molecular phenomena like paramagnetism of some molecules, some bone length orders. So this type of phenomenon was undescribed by the theories proposed earlier. So now the basic question is what is the difference between molecular orbital theory and others? Means hybridization say. So molecular orbital theory is mainly the linear combination of atomic orbitals. That means in case of molecular orbital theory, we uh, take the case of combination of atomic orbitals of two different atoms or elements. But in case of hybridization, we see only mixing of atomic orbitals of the same atom. That is the difference main. Second thing is molecular orbital theory is based on molecules. But hybridization first applies to a single element, then it gets applied to the molecule it forms. So how a molecular orbital is formed? So say two atomic orbital 1 plus atomic orbital 2, say two atomic orbitals are mixed, combined, then two types of molecular orbitals are formed. The one with the lower energy is called bonding molecular orbital BMO, and the one with higher energy is called anti-bonding molecular orbital, that is ABMO. So how these atomic orbitals are formed? These atomic orbitals are formed by the combination of atomic orbitals of the individual atoms, and in case of bonding molecular orbitals, the energy is low, that means electrons are high. Anti-bonding molecular orbitals energy is high, that means electrons are low. For example, this is an wave function of an orbital, say psi1 square. This is another wave function, same psi2 square. That means this wave function indicates, this square of the wave function indicates the probability of finding the electron. As these interactive phases are same, so its electron probability as a result of its combination will be increased, বাঢ়ি যাব. So বাঢ়ি যোৱা, that means কি তাৰ ক্ষেত্ৰত ৰিজাল্টিংটোৰ আমাৰ এনাৰ্জিটো কমি যাব, কিন্তু ইলেক্ট্ৰন probabilityটো বাঢ়ি গুচি যাব. That means মই যদি এতিয়া psi1 plus psi2 square যদি মই যদি solve কৰোঁ, তেতিয়াহ'লে মোৰ ওলাব psi1 square plus psi2 square plus 2 psi1 psi2. This much of electron density is increased in case of what? Is increased in case of bonding MO. Bonding MO. In case of bonding MO, this much electron density will be increased. That means that is why electron density increases and energy decreases. Similarly, in case of anti-bonding molecular orbital. This is an constructive phase. These things we get to learn in physics. Constructive phase interaction, these two orbitals interact or combine in the same phase. So its electron density is increased and its energy decreased. Similarly, for antibonding molecular orbital, the phase is what? Different in this way. Positive, negative. In this case, what will happen? The electron density will decrease. Positive, negative. So what will happen? Psi1 minus psi2 square will be seen in case of the resultant molecular orbital. So what will happen? This will attribute or contribute to what? Decrease in electron density. This much of electron density will decrease in case of what? ABMO, antibonding molecular orbital. So in case of antibonding molecular orbital, the electron density in the internuclear region decreases because of this destructive phase interaction, and in case of bonding molecular orbital, the electron density in the internuclear region increases because of constructive phase interference, constructive phase combination by interaction. Okay, now we have clear understanding about bonding molecular orbital and antibonding molecular orbital. So now we will discuss about the energies of the orbitals. So for energies, first we have to write this. For s atomic orbital, there appears two atomic orbitals, molecular orbitals, sigma star for s atomic orbital. After mixing, when s orbitals mix, then what molecular orbitals will form? Sigma bonding, sigma star antibonding. Similarly, p pi star. In case when p orbitals combine of two different atoms, then two atomic molecular orbitals will form. One will be pi and the other will be pi star. Similarly, for d, we have phi, we have delta star. Similarly, for f, we have pi star. So these two, d and f, are not used much or questions rarely come. So we have to give more focus on these two atomic orbitals s and p and molecular orbitals sigma star pi star. So the general trend for this is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px is equal to pi 2py is equal to pi star 2px is equal to pi star 2py sigma 2pz star. So this is the actual trend of energy of atomic orbitals. This is actual. Now one thing is to be remembered in case of molecular orbital theory. আমি এটা কথা মনে ৰাখিব লাগিব কি যে molecular orbital theory যেতিয়া আমি atomic orbitals molecular orbitals বনাও, that means কেনেকৈ ফৰ্ম হয় ইহঁতি linear combination of atomic orbitals. So combination of atomic orbitals, how they combine is very much important to know. So 2 points are to be remembered here. First one is যিমানে সাইজটো এটমৰ বাঢ়ি গৈ থাকিব সিমানে কি হ'ব, যিমানে সাইজটো এটমৰ কমি গৈ থাকিব বা এলিমেন্টৰ কমি গৈ থাকিব, যেটো আমি পিৰিয়ডত দেখো, সিমানে কি হ'ব S আৰু P ৰ মাজৰ ডিসটেন্সটো বাঢ়ি গৈ থাকিব যিমানে সাইজটো কমি গৈ থাকিব S আৰু P ৰ যিমানে ডিসটেন্সটো বাঢ়ি গৈ থাকে that means SP মিক্সিংটো কম হ'বলৈ লয় SP মিক্সিংটো যদি কম হ'বলৈ লয় তেতিয়া হলে কি হয় আমাৰ SP যিটো মিক্সিংৰ কাৰণে হোৱা মলিকুলাৰ অৰবিটেলত যিটো চেঞ্জ হয় সেই চেঞ্জটো যিমানে সাইজ কমি যায় নোহোৱা হৈ যায় সো আমি কিহত গুৰুত্ব দিব লাগিব তেতিয়া হলে সাইজত গুৰুত্ব দিব লাগিব when we form molecular orbitals and fill energy fill electrons sorry so let's say hydrogen molecule H plus H equal to H2 so hydrogen first of all let's say this is the energy always remember a energy sign to সদায় দিব লাগিব মানে from lower levels to upper levels only we assign atomic orbitals so 1s similarly for hydrogen this is 1s okay in case of H2 molecule hydrogen the electronic configuration is 1s1 so in this electron is 1 so sigma star 1s sigma 1s and sigma star 1s always remember the energy of bonding molecular orbital is always less than that of the parent atoms parent atomic orbitals energy always less and in case of antibonding molecular orbital the energy is always higher than parent atomic orbitals so first of all molecular orbitals lower energy will be filled bonding antibonding there will be no electron because only 2 electrons are there so in case of H2 molecule the electrons are highly bonding in nature that is why in case of the H2 molecule is very stable and also remember the atomic orbitals of hydrogen are in higher energy it is excited in case of H2 molecule it is of lower energy it is stable so H2 molecule ionization energy is always more than hydrogen ionization hydrogen atom ionization energy always remember this fact hydrogen molecule ionization energy is always greater than this because hydrogen atom is very stable H2 so that is why hydrogen does not exist as an single atom it exists as a molecule this is because of the reason because it is highly bonding in nature these electrons so it combined to form H2 molecule to become more and more stable similarly for bond order that means how much the order of the bond or it is single bond it is double bond then for this reason bond order is assigned and bond order is assigned by number of electrons in the bonding molecular orbital minus number of electrons in the anti-bonding molecular orbital divided by 2 in this case there are 2 bonding electrons in bonding molecular orbital anti-bonding 0 divided by 2 equal to 1 therefore 1 bond which is sigma bond because here only sigma electrons are used for the formation of the H2 molecule so this bond is what sigma bond so how this sigma bond pi bond is formed or which type of bond is formed we also have get knowledge about this from this molecular orbital theory so carbon molecule key formation hoy NO, nitrogen oxide, NO2, dioxide. Similarly, for other molecules also, yet key molecule kenuka bone formation hoy. Hetu ami from the knowledge of its molecular orbital diagram, we only get to know it. So this also helps in knowing the type of bone it forms. Similarly, the magnetic character also we get to know from this. It is what? 1 and no unpaired electron, so it is diamagnetic. So similarly, we get to know about this all from this diagram only. So again, I want to learn it from the basics. This is 1s. This is 2s. This is 2s. So this is sigma 2s. This is sigma star 2s. This is 2p. 2p. This is what? Sigma 2s. Sigma 2pz. This is pi. This is pi 2px. Pi 2py. 2p. Pi star. Pi star. 2px. 2py. Sigma star. 2pz. The general trend of energy is this. Okay. Now let's say the main thing appears here between these two. What happens? In case of sigma star 2s and sigma 2pz, S and P. So this energy is quite low. Okay. But in case of this, it is quite high. So as this energy is low, energy difference is low. So this sigma 2pz and sigma star 2s combine. That is sp mixing occurs. So what I say is that as thus up to what size is larger, when size is larger, sp mixing occurs, and because of this, the sigma star 2s and sigma 2pz combine, as a result of which the lower orbital energy slightly decreases and the upper orbital energy slightly increases. The increasing one increases, decreasing one decreases. So that is why after mixing, when electrons are filled, these atomic orbitals mix, as a result of which these energies are this. After mixing, sigma star 2s slightly goes down. Similarly, sigma 2pz goes up. Pi 2px 2py. So why this? Because of when the size is large, this sp orbital distance is low. So as a result of which they get mixed after electron filling. This electron filling they get mixed, as a result of which the lower one's energy becomes more lower and upper one's energy becomes higher. So up to which this is seen, the abnormality in the order of molecular orbital is seen up to nitrogen. Up to nitrogen it is seen. Sigma 2pz is higher than pi 2px, pi 2py. But in case of oxygen, from oxygen, fluorine, neon. For oxygen, fluorine, neon, as these their size is smaller size, so greater distance between sp, so sp mixing do not occur. So in case of oxygen, fluorine, neon, due to smaller size, these S and P do not mix. As a result, sigma to pz is in the lower side, and pi to px, pi to pa in the upper side. So this a point to ami in case of drawing molecular orbitals up to nitrogen and after nitrogen, eto ami mora rakhibo lage je from oxygen or pora lower size or kane sigma to pz tol dahe jehetu sp mixing nohoy, aru up to nitrogen ami jetia lithium beryllium ebu akim tetia hole amar sigma to pz to upor le jay because of sp mixing larger size. Okay, eto bostu by clear. Etia ami beleg combination of questions ami koribo parim jetia ami ei protitu diagram ami akibo paru. So everyone try to draw the molecular orbital diagrams from lithium to at least fluorine, depending on this sp mixing size, etc. Calculate its bond order, ionization energy, and this, and try to find every detail from it, and ask questions so that I can continue again with your doubts. So this class, a class tut moi ki korisu je mur phalopa moi jekhini problem thakiba boli hobo sekhini moi kori disu, কিন্তু তোমালোকে যেতিয়া কিবা ডাউট দেখুৱাবা বা ডাউট দিবা যে এইটো বস্তু প্ৰবলেম আছে বা এইটো ইনফৰমেশনটো পাব লাগিছিল বা এইটো বস্তু এইকনত যে আহিলে বেলেগত কিয় নাহিলে, এনেকুৱা কিছুমান কোৱেশ্চন কৰিলে মই গম পাম যে সেই পইণ্টত ঠিক আছে মই ভাবিব লাগিব, মোৰ ফাৰ্স্ট যেহেতু মই ভাবিব লাগিব বা মই অলপ পঢ়িব লাগিব, এনেকুৱা কথাবোৰ গম পাম। সেইটো মতে মই নেক্সট ক্লাছত আইডিয়া কৰি সেইটো নলেজ বা সেইটো কোৱেশ্চনত মই আনসাৰ দিব পাৰিম। কিন্তু এজ এ ফাৰ্স্ট ক্লাছ মই ইমানলৈকে ক'লো, এইখিনিৰ পৰা তোমালোকে কন্টিনিউ কৰি নিজে চোৱা আৰু এনি প্ৰবলেম সুধি ক্লিয়াৰ কৰি ল'বা যাতে মই আকৌ নেক্সট ক্লাছত এইটো বুজাও। সো আজিলৈ ইমানে, থেংক ইউ সো মাচ। সো ভিডিঅ'টো যিমান পাৰা শ্বেয়াৰ কৰিবা সবৰে লগত যাতে ক্লাছটো ইণ্টাৰেক্টিভ হয়। সো থেংক ইউ সো মাচ।